Okay, this is an overview of the lesson that you had in class today. Your task was to find all the zeros of the polynomial and then write the polynomial in factored form with factors of degree 2 or 1. So let's take a look at some specific details that can help us out. First of all, we want to list all of the possible factors in this format. Okay, so let's think about our very final constant. We're going to be focusing on this number here. That's the last number in this, and you're thinking about how it turns out when you multiply a bunch of linear terms together, when you multiply a bunch of binomials together, well, all of the factors need to be factors of 6. So a factor could be x and positive 1, because 1 divides evenly into 6. It could also be minus 1. It could also be 1 plus or minus 2. It could be x equals plus or minus 3. It could be x plus or minus 6. And that's pretty much it. So could x plus or minus 5 possibly be a factor of this? Well, no. 5 does not go evenly into 6. So let's check on what the next task is. So could this be? No. Not all of the possibilities. Those were just a list of possibilities. Well, not all of them will actually be factors. So now we turn to the graphing calculator to help decide which ones we're going to be checking as the best possibilities. So let's pull up a graphing calculator and give this a try. So back to the original. Here's my graphing calculator. I'll move that over so I can see. Oops. Okay, I've typed the equation in and let's graph it. And there it is. So with what we're looking at, what are our possibilities? Well, I kind of like to zoom in. Okay, so this is a little hard to see, so let's zoom in a little. Okay, what do we have here? I can see it approximately goes through a -1. So if it's going through a -1, one of our roots is likely to be x plus 1. And this looks like it goes through a +2, so another root is possibly x minus 2. Okay, so let's take a look. Alright, so we decided that our possibilities are x minus 1 and x minus 2, actually plus 1 because it was a -1. Alright, so with that, we need to do a bit of polynomial division and see what we can get. So let's set that up. X plus 1 on the side. Let's try this one first. So I've got an x to the 4th power here. 4th. So I know that x cubed times x makes x to the 4th. So I'm just going to fast forward here a little bit. Okay, so I need a negative x to the 3rd power, so this must be a -2x cubed. So this would be -2x squared. -2x squared. We need another -3. -3x times 1, -3x. We need a +6x to make this sum work. So this must be 6. And 6 times 1 is 6. And these match. That means this went in evenly without a remainder. So we've verified that x plus 1 is one of the roots, one of the linear factors. So we've got x plus 1. Now let's try another one. The other two didn't look very, two of them on the graphing calculator didn't look very exact. This one looks pretty exact. This one looks kind of out there in the middle. It might be kind of decimal-esque. And this one as well, but we could try this one. So let's go do that. Okay, so I'm going to record this up here. This is my result after dividing by x plus 1. So I need to record that. And now I know that x plus 1 times all of this is equivalent to our original. Okay, so the next idea that we have is to check this one. So we're going to take and see if this will divide evenly into this piece. So we're going to do another set of long division. So there's our x minus 2. And I need that to equal x cubed. So this first piece is x cubed. And minus 2x squared minus 3x and plus 6. So x squared negative 2x squared 0x squared. So this must be 0. So it's 0 x's times x that makes 0x squared. So it's kind of weird. But 0 x's times negative 2 makes 0 x's. And 0 x's together with this box need to make negative 3x. I'm going to put negative 3x here. And then I've got negative 3 times x makes this box. So negative 3 times negative 2 makes positive 6. And yay, again, no remainder. They match. So, in the end, our remaining is x plus 1 as a factor, x minus 2 as a factor, and x squared minus 3. We don't need to include this because it's 0. Okay, so now this is pretty much factored as much as it is going to be. There's a couple of options that we could do with this. We could go ahead and just apply it to the zero product property. Yeah, we could factor this, but it'd have square roots in it. We're going to get the same result if we just take and apply the zero product property right now. So if our outcome, our p of x, is 0, then what's going to make each of these binomials 0? Well, our roots will be at x is negative 1 from this one. X is positive 2 from this one. And from this one, if our x squared minus 3 is equal to 0, we add 3 to both sides, and we've got x squared is equal to 3. You square root both sides, and you end up with x is equal to plus or minus 3. So we've got 4 real results. Negative square root of 3, positive square root of 3, negative 1, and positive 2. There's our 4 real roots, and we knew by looking at the picture on the graphing calculator that those would all be real because there's 1, 2, 3, 4 intersections on the x-axis. And so that's the process for which we find all the zeros of a polynomial. And to write it in factored form, here we have it. It says factored form either degree 1 or 2. Well, this one has a degree of 1. This has a degree of 1. This is not quite ready yet. So we could actually factor that, and it would look like p of x is equal to as we know, a difference of squares can be done as x, positive, negative, and then the square root of this number. Well, since that doesn't square root equally, we can just do it like that. And then the other possibility is when we do the zero product property, we can see there's our positive 3 from here, our negative 3 from here, and so on. And that's the end of this video.